All right, so here's our first full out proof. So this is all by ourselves. So we need to prove that angle BAD, this angle here, is congruent to CAD, this angle here. So it would be helpful to prove that this triangle is congruent to that triangle, right? We got to do that some way, somehow. So what are we given? Well, we're given angle DBC is congruent to angle DCB. Now, if I ask myself, will that be helpful? These two angles are not in those two triangles. Well, that kind of stinks. Well, let's keep going. And AB is congruent to AC. Okay, so we get that. Now, I do know that AD will be congruent to itself by reflexive property. So that's a side and that's a side, right? So the question is, where's my third thing going to be? We can't use these right here at A because we need to prove them, right? So why in the world would it give us this angle and that angle congruent? Well, here's the question, right? The question is this triangle down here that we are not really going to use. What type of triangle is this going to be now? Well, if it has two congruent angles, it's going to be isosceles. This is your base, so then the other two sides will be congruent. And look at that. That is the third side in these two triangles that are congruent. These two triangles will be congruent by side, side, side. And then we can say that those two corresponding parts are going to be congruent by CP, CTC. That's the proof. So I'm glad we did this one because I wanted to show you how to use the isosceles triangle theorem in a proof. This is something that we haven't really done yet. I did not focus on them with you, but we got to throw it in now. Okay, so let's piece it all together. So my first step is going to be talking about these two sides in this isosceles triangle. So these two sides will be congruent. We'll call them DB and DC. They will be congruent because in a triangle, sides opposite of congruent angles are congruent. Great. Then I'm going to mention the reflexive side, AD, to itself because of the reflexive property. Great. And now there is, again, to refresh you, there is my side, side, side for those two triangles. So now I know my triangles are congruent. I'll use the same lettering as the angles I want to prove congruent, BAD, CAD. This is by side, side, side. So then if those two triangles are congruent, all the other parts are congruent. That means that all three angles in this triangle are congruent to all three angles in that triangle. So I know that angle BAD is congruent to CAD because they are corresponding parts of congruent triangles and they're congruent. Done. Green check mark. Let me get that bigger check mark just to feel good about myself. Yes. Okay, another proof coming. All right, great. Here we go. Another humdinger of a proof. So we have to prove that segments A, B, and CD are parallel. Oh my goodness gracious. How in the world am I going to do that? Well, remember, when you see parallel lines, you better be thinking of angles, and we're going to focus on the congruent angles because we're doing congruent triangle proofs, okay? So we want to prove that AB and CD are parallel. So obviously, right, we have two triangles, this triangle and this triangle. So why in the world would I want to prove them congruent? Well, here's my parallel lines. Let's use BD as the transversal. Do you see the Z? Right? If we can show that those two alternate interior angles are congruent, then that means the lines are parallel. So we want to show that these two angles are congruent, angle B and angle D. Well, in order to show that, if we can show the triangles are congruent, then we can use CP, CTC. So we have this idea of being bisected in our given, which means we have two congruent parts. Notice it says these segments bisect each other, so that means we have two things being bisected, okay? And then where's the third thing going to come from? Well, look at how these triangles are drawn. We have this intersecting here. Do you see the V up and the V down? Aren't these vertical angles? So we're going to use vertical angles and the fact that they're congruent as our other pieces. So there we go. That's our proof. So if BD is being bisected, it's broken into two equal parts. If AC is bisected, it's going to be broken into two equal parts. And here is my side, angle, side. That's why the triangles will be congruent, side, angle, side. So I just did all the proof with you before we actually did the proof, right? This is the thought process. This is what I'm thinking of on my little piece of scratch paper before I do the proof. Okay, so let's actually write it out. So I am going to start with BD, right? BD is going to be broken into BE and DE. BE, DE. Segment bisector, something like that. I'm looking for a segment bisector divides into two congruent segments. Yes, it does. I also know that AC is being bisected into AE and CE. And again, this idea of a segment bisector divides a segment into two congruent segments. Sure. So there's my two sides. And now the vertical angle pair. They're going to be congruent. I'll call the top one AEB. I'll call the bottom one CED. They are vertical angles, and vertical angles are congruent. So why are these two triangles congruent? These two triangles are congruent by side, angle, side. So we have to be careful on the naming, right? So we have to name them in corresponding order. So if I call the top one A, E, B, you need to know that AE corresponds to CE. They're the double mark sides, so CEB. It's very important when you name the triangles that you're corresponding, and that is side, angle, side. Okay, so see, it says CEB is not a triangle, so I wasn't paying attention, right? CEB is not a triangle, it's CED. But notice that I use that information to help me, right? So don't be like, oh, I got it wrong, right? Just fix it. It happens. Good. And now that the triangles are congruent, again, remember I talked about to prove that the lines are parallel, prove that this line and this line are parallel, use this as your transversal and use angle B and angle D. They're now congruent because the triangles are congruent. So we can now say that angle B is congruent to angle D, and it's not by alternate interior angles. We're not there yet. It's by CPCTC, right? Yes, they're alternate interior angles, but the reason they're congruent is by CPCTC. We don't know that the lines are parallel, but now we do because we just showed alternate interior angles are congruent. So now we can say that yes, AB is parallel to CD because if two lines are cut by transversal and form congruent alternate interior angles, then they're parallel. Awesome. There we go, green check mark. So again, proofs are not easy. The more you do, the better. All right? So ask for help if you need them, but create a plan and go with it. All right, very good. I got one more video coming with two other different types of problems.